Yes, my dear students of 10th standard, I welcome you all in the name of Lord Jesus to listen and understand the lesson solution. Already we have discussed in the previous class about what is mixture, and when these mixtures are homogeneous mixtures, components are not able to see in the naked eye. If the components are uniformly distributed in the solution, then we can call it as homogeneous mixture. Suppose the components are not homogeneously, that means not uniformly distributed, that is called a heterogeneous mixture. Then also we have learned about the importance of solution in our day-to-day life. For example, the liquid found in a human body also in the form of solution, blood, lymph, and also seawater, air are also in the form of solutions. And the components of solutions, mainly two important components. One is solid, another one solvent. Solid is nothing but the component which is present in lesser amount by weight, and solvent is the component present in a larger amount by weight, that is called solvent. When the solid is lesser in amount, then only we will get a homogeneous mixture, that will be called as solution. Then based on the component, we are classifying binary solution, ternary solution. If suppose solution which are made of one solid and one solvent, that means if solution contain two components, and it is called binary solution. Example, sugar in water, salt in water. Suppose solution contain three components, for example, sugar, salt and water. There are three components. Then we can call it as ternary solution. Then the types of solution based on the physical state, it is going to be classified into three categories, that is solid solution, liquid solution, gaseous solution. But already we have learned solid alloys, liquid solids, amalgam. The liquid solution, solid in liquid, salt in water, liquid, alcohol in water, gas in liquid, carbon dioxide in water, gaseous solution, liquid and gas, water vapor, cloud, gas and gas, mixture of helium, oxygen gases. Then in this mixture of helium, oxygen gases, helium is active as an inactive one, which is less soluble in blood. The helium is very less soluble in blood. That's why helium is used to mix with oxygen. These helium oxygen mixtures are used by the deep sea divers, the people, those who are doing research under the sea water, used this type of cylinders having helium oxygen gases because why helium is mixed? Helium is less soluble in blood compared to nitrogen. Then based on the type of solvent, water is a universal solvent. So water is going to dissolve most of the things, but some of the things are not soluble by water. So based on the two classification, aqueous solution, non-aqueous. If water acts as a solvent, that is aqueous solution. Example, common salt in water. Then any liquid other than water acts as a solvent, that is called non-aqueous solution. That is sulfur in carbon disulfide. Then based on the amount of solid, three classification: saturated solution, unsaturated solution, supersaturated solution. Based on the amount, how much of solid is in this given amount of solvent. Saturated solution means more solid is dissolved in the given amount of solvent. That means no more solid can be dissolved in a definite amount of solvent at the given temperature. For example, at maximum 36 gram of sodium chloride can be dissolved in 100 gram of water at 25 degree. So this is going to give a saturated solution. Then unsaturated solution means the solution contains less amount of solid compared to saturated solution. That is unsaturated. Then supersaturated solution means solution contains more solid than the saturated solution at the given temperature. Suppose 40 gram of sodium chloride in 100 gram of water at 25 degree means that is supersaturated solution. Then next we are going to study about concentrated and dilute solution. What is called a concentrated solution and what is called a dilute solution. Actually, it depends upon the amount of solid present in a solution. That depends upon the amount of solid present in a solution. Based on this only, it can be called as a dilute solution or concentrated solution or saturated solution. The amount of solid present in the given amount of solvent. For example, if you are given 2 cups of tea, when you are going to taste them, if you feel the one is sweeter than the other, then you are going to say the tea which is sweet more contains higher amount of sugar than the other. So we are going to express the tea is stronger. Suppose the tea contain more decoction, the coffee contain more decoction. What you are going to say? You are going to say that tea or coffee is more stronger. So by observing the color, by observing the physical characters such as a color, density, we can say whether it is stronger or dilute or less stronger. But the word stronger is used by as in common. But chemists would say that it is a concentrated. Instead of stronger, chemists say it is a concentrated solution. So we are going to compare two, that is solid and solvent in a solution. The one which contain higher amount of solid, the solution which contain higher amount of solid for the given amount of solvent is called concentrated, and which one contain less amount of solid in the given amount of solvent is called a dilute solution. So you have to understand clearly. Suppose in 100 gram of water, 36 gram of sodium chloride dissolved means that is concentrated. Suppose the other solution in 100 gram of water only 20 gram of sodium chloride is dissolved means compared to the previous one, this is dilute. So this is the dilute and concentrated. These terms are given by comparing two solution. So it will not going to say about the the quantity of solid. It does not imply the quantity of solid, how much of solid is present in the solution, but we are going to compare two solutions which contain more solid than the other, See the figure 9.5. Here two beakers are given. First beaker, a less amount of solid. The solid particles are very less compared to the second beaker. The second beaker, more solid particles are there. So we can say first one is dilute solution compared to the second one. The second beaker contains more solid compared to the previous one. So the second beaker is having more concentrated solution. And it is a qualitative representation. So it's going to determine the nature of substance present in the mixture. So it will not going to imply the quantity of solid, and the difference is observed by means of seeing the color, density, etc. Then what is in the activity 1? Look at the following picture, label them as dilute and concentrated solution and justify your answer. See the first part, it is given tea, 2 teacups are there. In the first teacup it's going to be more brownish, going to be the second one. The first one is concentrated compared to the second one, concentrated, because in the first teacup more tea decoctions are there, more solid particles are there, so it is going to be concentrated. By seeing the color we can say whether it is concentrated or dilute. And second one, see, two beakers are there. First beaker is going to be more dark blue color, second one very light blue color. So the more darkness of blue color says it contain more copper sulfate. So solid particles are more in the first beaker compared to the second one. So the first beaker having concentrated solution than the second one. Then solubility. It is nothing but usually there is a limit to the amount of solid that can be dissolved in a given amount of solvent at given temperature. We cannot dissolve whatever the amount of salt or solid in the given amount of solvent. There is a limit. For example, see, only 36 gram of sodium chloride can be dissolved in 100 gram of water at 25 degree. Only 36 gram of sodium chloride can be dissolved in 100 gram of water at 25 degree. So that is the maximum capacity of solid that can be dissolved in the solvent. So that going to give a saturated solution. Suppose any excess of solid that is added simply reside at the bottom. Suppose if you add more than the 36 gram of sodium chloride in 100 gram of water, what will take place? The excess of solid added is going to be simply settled down at the bottom of the beaker, bottom of the solution. That will not going to be dissolved. So the extent of dissolution of solid in a solvent can be better explained by its solubility. So what is called solubility? It is nothing but the measure of how much solid can be dissolved in specified amount of solvent. It is the measure at the degree of how much of solid, how much of salt or how much of sugar can be dissolved in specified amount of solvent. For example, specified amount means we take only 100 gram of water. So how much of salt can be dissolved in 100 gram of water, or how much of sugar can be dissolved in 100 gram of solvent. So that going to give the solubility of that solid. Then next one, see, there is a definition, so you can note down and underline. What is the definition for solubility? Solubility is defined as the number of grams of solid that can be dissolved in 100 gram of solvent to form its saturated solution at a given temperature and pressure. So that is the definition. The first 4 lines. It is defined as the number of grams of solid that how much of solid that can be dissolved in 100 grams. So we are taking the solvent as a definite amount 100 gram. So how much salt is dissolved in 100 gram of water to attain this saturated solution at this given temperature and pressure. That is called the solubility. For example, 36 gram of sodium chloride need to be dissolved in 100 gram water to attain saturation at 25 degrees. So what is the solubility of sodium chloride in water is 36 gram. Solubility means the maximum capacity of salt that can be dissolved in 100 gram of water at 25 degrees. That is 36 gram. So solubility of sodium chloride is 36 gram. Then I will express it in mathematical form. That is, there is a formula to calculate solubility. Solubility is equal to mass of the solid taken. Mass of the solid. What is the mass of solid? 36 gram. What is the mass of solvent? 100 gram. So 36 by 100 into 100. You can cancel 100. Solubility of sodium chloride is 36 gram. 36 gram. Similarly, you can solve the problem using this formula. Then some examples are given in table 9.2. Solubilities of some common substances in water at 25 degree at normal temperature. So calcium carbonate CaCO3 in the solid state can be dissolved 0.0013 gram per 100 gram of water. So very less amount of calcium carbonate can be dissolved in 100 gram of water. More or less it will not going to dissolve. Then sodium chloride 36 gram can be dissolved to attain the saturation. Ammonia in the form of gas, NH3, it is a gas, 48 gram can be dissolved. Then sodium hydroxide in the form of solid, 80 gram of sodium hydroxide can be dissolved in 100 gram of water to attain saturation. Then glucose, C6H12O6 solid, that is 91 gram of glucose can be dissolved in 100 gram of water to attain saturation. Sodium bromide, NaBr in solid state, 95 gram of sodium bromide can be dissolved in 100 gram of water to attain saturation. Then sodium iodide, NaI, sodium iodide in solid state, 184 gram. So see, the amount of sodium iodide is more than the amount of solvent. So that is the solubility of sodium iodide. 184 gram of sodium iodide can be dissolved in 100 gram of water to attain saturation. So out of this, in the tabular column, sodium iodide is the maximum amount of solid that can be dissolved in 100 gram of water at 25 degrees Celsius to attain saturation. Then what are the factors affecting solubility? What is solubility? Solubility is nothing but that is the measure how much of solid can be dissolved in specified amount of solvent. How much of solid can be dissolved in a specified amount of solvent. It is called solubility. So there are three important factors. First one is nature of solid and solvent. Nature. Then second one, temperature. How temperature going to influence the solubility. Then third factor, how pressure going to influence the solubility. First factor, see, nature of solid and solvent. The nature of the solid and solvent play an important role in solubility. Although water dissolves an enormous variety of substances, both ionic and covalent, it does not dissolve everything. So the phrase that scientists often use when predicting the solubility is like dissolves like. This expression means the dissolving occurs when similarity exists between the solvent and solid. For example, common salt is a polar compound and dissolves readily in polar solvents like water. Non-polar compounds are soluble in non-polar solvents. For example, fat dissolved in ether. But non-polar compounds do not dissolve in polar solvent polar compound do not dissolve in non-polar solvent. So listen boys. So first to take this nature of solid and solvent. See, the nature of solid, normally ionic compounds are soluble in water because water is a universal solvent. Water is a universal solvent. So most of the substances are soluble. Ionic, some covalent compounds also soluble in the water. So water is a universal solvent. Even though all the substances are not dissolved in water, not dissolved in water. That's why see scientists use a term like dissolves like. What is the meaning of this one? Like dissolves in like. This sometimes this type of phrase will be used in the question form. Explained with an example like dissolves like. That is this type of questions are asked. Like dissolves like. Explain the term with a suitable example. So like dissolves like means the substances having the similarity or the substances having similar polarity can be dissolved in one another. Dissolved in one another. For example, see this expression mean dissolving occurs when similarity exists between solid and solvent. This is the meaning. If there is a similarity between solid and solvent, if the solid and solvent having same polarity, then dissolution occurs. Then dissolution occurs, which is going to give you a solution. For example, polar compound dissolve in polar solvent. This is the meaning. Polar compounds. For example, ionic compound, sodium chloride and sugar, calcium chloride. These are our polar compound. So polar compound dissolve in polar solvents. That is the meaning of like dissolves like, because similarity exists. Polar, this is a polar compound, that is a polar solvent. Similarity. So because of the similarity, it going to give you a homogeneous mixture. Solution will be formed. At the same time, see, non-polar compounds are soluble in non-polar solvents. Non-polar compound. So fat will not dissolve in water. Fat is a non-polar. So fat can be dissolved using ether, benzene like that. Ether, benzenes are non-polar solvent. So non-polar compounds are soluble in non-polar solvent. Fat in ether, wax in ether, benzene. And at the same time, non-polar compound do not dissolve in polar. Fat will not dissolve by water. Non-polar compound, fat will not dissolve by water. Similarly, polar compound do not dissolve in non-polar. Polar compound, sodium chloride, sugar, glucose, will not dissolve by ether, benzene. So you have to understand, like dissolves like means that the dissolution occurs when similarity exists between solid and solvent. The dissolution occurs when similarity exists between the solvent and solid because of the same polarity of the polar solvent and polar solid. Non-polar solvent and non-polar solid. Then second factor, effect of temperature. Effect of temperature. How temperature influences the solubility of the substance. Generally, solubility of a solid in a liquid solvent increases with increase in temperature. For example, greater amount of sugar will dissolve in warm water than cold water. So, when a solid going to dissolve in liquid, it going to depends upon the temperature. At normal temperature, for example, if you take 36 gram of sodium chloride can be dissolved in 100 gram of water at 25 degrees Celsius. If we increase the temperature of the solvent, temperature of the solvent is increased more than the 25 degrees Celsius, we can add some more gram of solid. More than the 36 gram of solid can be dissolved in the solvent. So temperature increase means it increase the solubility. It increase the solubility. So greater amount of sugar will dissolve in warm water compared to cold water. So already you have learned there are two terms in the temperature, regarding temperature. One is endothermic, another one exothermic. Already have learned in 8th standard and 9th standard. Endothermic process means nothing but a chemical reaction which involves the absorption of heat energy. The chemical reaction which involves the absorption of heat energy. And exothermic process means that chemical reaction which involve that liberation or revolution of heat energy. So in endothermic process, solubility increases with increase in temperature. Solubility increase in temperature. At the same time, exothermic process, solubility decreases with increase in temperature. So here, example is, you can see solubility of gases in liquid. Do you know why it is bubbling when water is boiled? Solubility of gases in liquid decreases with increase in temperature. In exothermic, this is an exothermic process. The solubility of the oxygen which is in the atmosphere slowly going to dissolve in water. So this solubility of oxygen is going to be decrease during the increase of temperature. So water contains dissolved oxygen. When you are going to heat the water, what happens? See, when water is boiled, the dissolved oxygen going to escape out. The dissolved oxygen escape in the form of bubbles. That's why, see, when the water is boiled, we used to see the bubbles. What is bubbles? Bubbles are nothing but the dissolved oxygen water escapes out. At the same time, aquatic animals live more in cold region, Antarctic region, Arctic region. So in this region, the temperature is very, very less. These are all cold regions. So more amount of oxygen is there in the water because the temperature decrease and the dissolution of oxygen increase. Temperature decrease, dissolution of oxygen increase. So these area that aquatic animals are more because more oxygen is present in the cold water. More oxygen. So this enables the aquatic animals to live more in number compared to the other region. This shows the solubility of oxygen in water is more at lower temperature compared to the previous one. Then effect of pressure. So this is mainly for gases. Effect of pressure is observed only in the case of solubility of gas in liquid. So how will you going to express? When pressure increase, solubility of gas also increase. Simply you have to understand, when pressure is increased, solubility of gas also increase. So the solubility of gas is directly proportional to pressure. The solubility of gas is directly proportional to the pressure. That means what? Pressure increase, solubility also increase. Pressure decrease, solubility also decrease. For example, see, the preparation of carbonated beverages like soda water and all type of beverages, Coca-Cola, Coke, Miranda, all these beverages, that carbon dioxide is dissolved. Carbon dioxide is dissolved by applying more pressure. Then, so in the Moore note is given, see, it's going to give one law, that is Henry's law. This Henry's law going to say the effect of pressure and the solubility of gas in liquid. The effect of pressure and the solubility of gas in liquid is given by Henry's law. Sometimes this will be asked in 2-mark question. Define what is called Henry's law. It is nothing but the same thing what we have discussed earlier. That is the solubility of gas is directly proportional to the pressure of the gas. That is simple thing you have to understand. The solubility of gas in liquid is directly proportional to the pressure of the gas at definite temperature. The next term, concentration of solution. So far we discussed what is solution. So solution is a It is a homogeneous mixture of solute and solvent. It is a homogeneous mixture. What does it consist of? Types. We have learned. What does it consist? It consists solute and solvent. And types we learned about the that is a physical state, and also based on the solvent used, based on the amount of solid, we have discussed the type. So most of the chemical reaction take place in solution form. So it is essential to quantify the solid in solvent to study the reaction. To quantify the solid in solvent, we can use the term concentration. So most of the chemical reaction take place using the form of a solution state, the liquid state. So we are going to study about concentration. What is concentration? Then the definition is given. Concentration of a solution may be defined as amount of solid present in given amount of solution or solvent. These things only already we have learned in the concentrated and dilute solution. The amount of solid in given amount of solvent. The amount of solid in given amount of solvent. So in the quantitative concentration of a solution may be expressed in different methods, but here we shall discuss percentage by mass, and percentage by volume. We are using two different methods to express the concentration. One is percentage by mass, another one percentage by volume. So first one, see mass percentage. What is called mass percentage? The first two, three lines are definition. Mass percentage of a solution is defined as the percentage by mass of solid present in solution. So, how much percentage of mass is in the solution? That is called how much percent of solid is in this solution. That is called mass percentage. It is mostly used when solid is solid and solvent. So here, when the solid is solid and solvent is liquid, when the solid is solid and solvent is liquid, we use this mass percentage term. The formula for mass percentage, mass of the solid by mass of the solution into 100. This is the simple formula. Then next one, see, also we can write that the mass of solution is nothing but that is the addition of solid with the solvent. So mass percentage can be written in another form. Mass of solid divided by, already in the previous given, mass of solution. What is mass of solution? That is mass of solid plus mass of solvent. That is called mass of solution into 100. For example, see 5 gram of sugar solution. 5 gram of sugar solution by mass means of 5 gram of sugar in 95 gram of water. Hence it is a 100 gram solution. So for example, see 5 gram of sugar solution, you have to write 5 in the numerator, and the denominator you are going to write the solution is going to be 100 gram. 100, that is a 5 by 100 into 100. You can cancel 100. That's going to give you that is a 5% of sugar solution. 5% of sugar solution. So mass percentage is 5%. So usually mass percentage is expressed as W by W. That is a weight per weight. Weight per weight. Mass percentage is independent of temperature. So next one, see volume percentage. So volume percentage is defined as the percentage by volume of solid in the given volume of solution. So in the mass we are taking that mass percentage by mass. Here we are taking percentage by volume. That's all. Percentage by volume of solid in the given volume of solution. Here the term volume is used, there the term mass is used. So volume percentage is equal to volume of solid by volume of solution into 100. Also we can write that is volume percentage equal to volume of solid by volume of solid plus volume of solvent. We have solution is formed by the combination of solid with solvent. So we can write volume of solid plus solvent into 100. One example is given, see 10% by volume of solution of ethanol in water means 10 ml of ethanol in 100 ml of solution or 90 ml of water. I will going to write in this formula. See, you can write the volume of solid is 10, volume of solution is 100 into 100. We can cancel 100. So 10% by volume of solution of ethanol. Usually volume percentage is expressed as V per V, that is volume per volume. Volume per volume. It is used when both solid and solvents are liquid. Here both the things are in the state of a liquid. In the state of liquid. It is used when both the solid and solvents are liquid. Volume percentage decreases with the increase in temperature. So when temperature increase, the volume percentage decrease. Because temperature increase, what happens? See, the liquid going to expand slowly. Expansion take place. The molecules, the atoms present in the liquid slowly going to expand. So the percentage decrease. Then you can notice that in the commercial product that we come across in our daily life, such as solution of syrup, mouthwash, antiseptic solution, household disinfectant, etc., the concentration of the ingredients is expressed as V per V, that is a volume per volume. Similarly, in ointment, antacid, soap, etc., the concentration of solution is expressed W per W, that is weight per weight. It is given, see, weight per weight, volume per volume, volume per volume. So this type of measuring quantitative measurement is used to represent the concentration. So my dear boys, so up to this you learn thoroughly. The next topic, hydrated salt and water crystallization, we will discuss in the next session. So what we have discussed now, see, listen. We have discussed about that concentrated and dilute solution. Concentrated and dilute solution. So if the solution contain more solid, that is going to be concentrated. That is going to be more concentrated. If the solution contain less amount of solid, that is going to be a dilute solution. So this is simply a comparative term, and is going to observed by means of a physical character like color, density, and solubility is nothing but, and that is going to be a measure of how much of solid can be dissolved in specified amount of solvent. So definition given, solubility is nothing but the number of grams of solid that can be dissolved in 100 gram of solvent to form saturated solution at a given temperature and pressure. Formula, solubility is equal to mass of solid by mass of solvent into 100. And factors affecting solubility, there are three important factors: nature of solute and solvent, temperature and pressure. And in nature, see, for example, see, ionic compound dissolve in, that is a polar solvent, that is polar compounds in polar solvent, non-polar compounds in non-polar solvent. The term is expressed using the phrase by scientists, like dissolve in like, dissolve like. That means what? That the dissolution occur when similarity exists between the solvent and solid. That is polar compound dissolves in polar solvent. Non-polar compound dissolve in non-polar solvents. So the effect of temperature, when temperature increase, normally solubility of the solid is increased. But in endothermic process, solubility increase with increased temperature. Exothermic, solubility decrease with the increase in temperature. Then in the effect of pressure, this is going to mainly imply that the solubility of gas in liquid. When pressure increase, solubility of gas also increase. The same thing is explained in the Henry's law. What is Henry's law? The solubility of gas in liquid is directly proportional to the pressure of the gas. Then concentration of the solution, that is nothing but the amount of solid present in the given amount of solvent. Amount of solid present in the given amount of solvent, that is expressed by, that is percentage by mass, percentage by volume. That mass percentage is the percentage by mass of solid in the solution. That is mass percentage is equal to mass of solid by mass of solution into 100. At the same time, what is volume percentage? That is the percentage by volume of solid in the given volume of solution. So volume percentage is equal to volume of solid by volume of solution into 100. So my dear students, you have to revise up to this and prepare well. Don't waste the time, note down. And also for the previous lesson, atomic structure, periodic classification, write classwork for the short answer, detailed answer, hard questions and problem. Write question, underline, and then answer. Learn thoroughly. And you have to write one test. I will give one test in the next section for the atomic structure. So you learn thoroughly all the objectives. You have to write test, objective test. Prepare well. Don't waste the time. Thank you. God bless you.